I'll be demonstrating the creation of a pendulum animation. The process begins with modeling the pendulum. In this instance, I decided to use 1, 2, 3, 4, 5, 6, 7, 8, and 9 instanced spheres with the same shape. And I will play the animation now just to demonstrate. In animation, you can see the pendulums swing in oscillations, and then they go out of oscillations, and as oscillations slowly expand until they are in sets of 2s or 3s, and then they end by returning to a normal oscillation, and then the process is repeated and looped. The effect is created with a node graph that takes the time info of the scene, the frame point in the animation. That number is then multiplied and used as a delay to the input of the time that is used in a list that is put through a sine function and multiplied by a constant 0.87 that is used in a function to generate the swing of each pendulum, I could say, to make it simple. More in depth, the time is multiplied, everything is delayed, you put into a sine function, and then in this list the specific delay for every single pendulum right here of the 9 is taken into account. It's retrieved from the list, put through a function of mass sine x plus mass pi times y, convert it to radians, and take the function of the value, the sine function of the value. That value is multiplied by y, which is basically just a constant for all of them, the scale at which it will rotate at, the distance from the center. From there, the vectors are combined to generate a motion or a transform for each object. It is then combined into a list and then output to a transform output. Each object is then instanced and outputs to the transform as well. Instancing the objects creates 9 sets of objects for each transform to output to. This node graph may look very complicated, but it is in truth very simple. However, it does take quite a while to come up with. Afterwards, to make the animation look good, we work on shaders. On the ground, we can see some lines that move around, and the lines move around and progress as the animation plays. They morph and combine. Also, we have, in a more detailed view, mirroring of a semi-transparent object to create this form of underlayer. The effect is created using 2 shaders mixed together. A simple transmission shader that is very smooth, not rough at all, allowing it to reflect easily, with a mid-range specular allowing it to reflect a lot of light. A wave texture, magic texture, and a bump texture are used to create a almost invisible bump in the plane as it moves to give it more depth. Texture coordinate is used to map the main textures for the visuals to Musgrave and put through the Musgrave texture is also mapped the Musgrave texture's modification of the general UV mapping is then sent towards a wave texture, which is then inverted, put to the power of 3.5, multiplied, and then put through a minima, comparing it to a gradient texture that is put to the power of 25 and multiplied. This effect basically gives the gradient that we can see surrounding the pattern. Without this, it would just be a large square with the texture on it, which wouldn't look very good. From the wave texture, we can generate the actual circles and lines that go around by using a wave texture with some distortion. The amplitude of the texture is multiplied by 5.6, and this is just a testing offset that can be used to change where the texture sits, where the lines are drawn, but I find it best at 0 actually, or maybe 0.1 depending on how I'm feeling when I'm going to do the final render. After that, I put it through a color ramp to take the black and white that would usually be generated, and through the color ramp I use a gradient of, I use a ramp of blue, green, blue, yellow, and orange, get a color like this, the different amplitudes for each amplitude from the wave texture. This is then used to color the previous wave texture. This is also a temporary coloring that could have been used to change the hue or the contrast, but right now it's idle. You can increase and reduce the darkness with this. Yes, I can increase and decrease the darkness. And all of it goes through a simple emission to a mix shader that's combined with the transparency and reflectivity to the material output to create a satisfying texture, I'd call it. And this is what we can get in the Eve render, because real-time rendering a complex scene like this is very difficult. From the top, it's very clear that they are in changing oscillations, and the oscillations are expanding.